Okay, guys, welcome back to the second part of this June 220 Mechanics Variant 4-1 paper. Okay, we have done the first four questions in the previous segment, and now we're going to complete this paper, inshallah. Okay, so people are getting in. So, guys, please be quick. Okay, if you read this question carefully, it says a child of mass 35 kg is swinging on a rope. Okay, the child is modeled as a particle P, and the rope is modeled as a light inextensible string. When it says light, that means you have to ignore the mass of that object, which is being labeled as light. Okay, length of 4 meters. Initially, P is held at an angle of this
Assalamualaikum, sir.
Walaikum salam, beta. 45 degrees to the vertical. Now, given that there is no resistant force, find the speed of P when it has traveled halfway along the circular arc from its initial position to its lowest point. Now, we were doing this question in the previous group and we were making a mistake. We were considering this point over here where he's asking for this, the speed. But he says half this circular part over here. Okay, so that half is going to be somewhere over here. Okay, and if I can draw exactly the lines to show that, so this would be like this. And if you people are familiar with the circle properties, these angles would be exactly half. Okay, so this would be 22.5, and this would also be 22.5. Okay. Now, when you have to find the speed here, we are given that the speed at this initial level, it was held at rest. So here your initial speed is zero. Okay. Your initial speed is zero here. So that is u equal to zero. We have to find the speed at this level. Okay. So we have to find what is the speed at this level. So there is no driving force. There is no resisting force. So this is clearly the situation where you can say that the gain in kinetic energy is equal to the loss into the potential energy. Okay, so obviously if you call this point, let's say this is the point, let me call this point, um, this is the point A here, and this is the point B over here. When it moves from A to B, it will gain the speed. Okay, kinetic energy will be increasing while moving from A to B. On the other hand, the potential energy will be decreasing while moving from A to B because its height is decreasing and potential energy depends on the height. Okay, now this is the trickier part over here is to determine how much height has been lost. For that purpose, I'll be using the lines over here. Okay, I'll draw this line from here. Okay, and then I'll draw another line, preferably in a different color. Okay, like this. Okay, if you let me label this, let me call this point O, and this is the point, let's say this is X, and this is the point Y, and here is the point Z, this point down here. Okay, so if you are able to find this XY efficiently, you can get all these 4 marks because you know that the gain in kinetic energy is going to be simply half mv square, because initially this is basically half into m into v square minus u square. Since your u is 0, so this is going to be half mv square. And then the loss in potential energy is going to be mg. Since you have moved this to the other part, so that don't worry about using the plus or the minus sign here. This will be written as plus here. Okay. Basically, the formula that works here, that is the work done by the driving force minus work done by the resisting force, that is the change in kinetic energy plus change in potential energy. This is the master formula. If you remember this, you can always, I mean, attempt these questions correctly. Acha bachcho, now let me say that this is the right angle here. This is the right angle over here. Okay. Who will tell me that what is the length OX? Hmm? What is the length OX? Can I say that is 4 cos 45? Yes, because if you consider the triangle OXA, this OA is 4. So this OX is going to be 4 cos 45. Yes or no? Guys, hurry up. Tell me quickly. Okay, no one is interested to. Then should I tell you to switch your cameras on then? Hmm? Hello? Hello.
जी सर.
जी सर.
Are you clear that this OX is 4 cos 45?
Yes sir.
Yes. And then what would be this OY then? Hmm? 4 cos 22.5, because this OB is also 4, and this is a right angle triangle OYB. Okay, should I draw this over here? This one is 4, this one is 22.5. Here is a right angle. So if you want to find this length, so that is going to be 4 cos 22.5, है ना? So if you want to find XY, so that would be 4 cos 22.5 minus 4 cos 45. So let me write it here. This is 4 cos 22.5 minus 4 cos 45. You can cancel m with m. This is going to be v square, that is 20 into all of this. And you find the square root, and you should get, let me see the answer from here. You must be getting the answer, that should be 4.16. Please do all that manipulation on the calculator and tell me, do we really get 4.16 meter per second or not? So people, they have confirmed that while doing all this working, we get the correct answer, that is 4.16 meter per second. Okay, now let's move on to the second part of this. And I would like to keep this diagram, okay? And I will see that, okay, so it is given instead that there is a resistance force, okay? The work done against the resistance force as P travels from its initial position to its lowest point. Okay, now it says lowest point. Okay, so he would be talking about this point Z over here. So that is X joules. So work done by the resisting force is going to be X joules. And it says the speed at its lowest point is going to be 4 meter per second. So speed at this Z, that is 4 meter per second. So we have to find that how much is this X. Let's go back to the diagram here, okay? And in fact, I would have to clear all the diagram, not all the diagram, but this part, okay? And this part, okay, this part, okay? And I'll have to remove this as well. Okay, guys, now it's moving from A to the point Z, okay? From A to the point Z. And we'll be using the same formula, the master formula over here, okay? And you will see that inshallah you will be able to handle that very efficiently. So now, work done with the driving force, there is no driving force, that is 0. Minus work done with the resisting force, that is X. We will find that X. So the change in kinetic energy, initially the speed is 0, finally the speed is 4 at here. Here you have the speed, it is 4 meter per second. So that is going to be half into the mass. We'll have to use the mass this time. That is 35 into 4 square is 16 minus 0 is going to be 16, okay? Plus mgh. So this is going to be m into 35, sorry, 35 into 10, that is going to be 350. And now the height lost this time is going to be, you know, that all of this is going to be 4 up to here. That is 4, and we already know that this length is 4 cos 45. Okay, so if I consider the, I mean, this is the final level over here. Okay, so if I say my h2 is 0 and my h1 is this height, that is 4 minus 4 cos 45. Okay, so that is going to be 0, the final height, minus initial height, that is 4 minus 4 cos 45. So this is going to be minus 4 plus 4 cos 45. So guys, please solve this equation. This is going to be minus x, that is 8 into 35, and if you simplify this, plus 350 into whatever you have here, tell me, you should have the answer. Let me give you the answer. That is 130, approximately 130. Do you get 130? Please use your
जी सर.
calculators. Okay, so this is confirmed. So this X is 130. The work done against the resisting force is 130 joules. So this X is 130 over here. Now, my student is asking that why are we subtracting this from zero over here? The thing is, the formula for the change in potential energy, that is going to be mg into the final height minus the lower, I mean, the initial height. We have to consider the height from the, like, from the lowest point here. So here the height is zero, and initially this was this much high over here. Okay, so uh, final minus initial, so final height is zero and the initial height is this much. So that is why I'm writing this zero minus all of this. Okay, I hope I answered your question. Okay, a question on kinematics too. A particle moves in a straight line AB. Let me draw that line AB here, the straight line AB. Okay, this looks like a bumpy straight line. Okay, so please forgive me for that. Okay, um, A is given, like the velocity of A is given as, the velocity is k times t square minus 10t plus 21. Okay, where k is a constant. The displacement of the particle from A in the direction towards B is 2.85 meter when the time is 3. So let's say when the time is 3, your x is 2.85 meters. That is the distance from A. When time is 6, it is 2.4. So it has got closer, okay? When the time is 6, your x is 2.4 meters. Okay. Find the value of k, hence find an expression in terms of t for displacement. If you read this question carefully, this becomes a P1 integration question where you have to write down the equation of the curve, because asking for the expression for the displacement. So you know that when you differentiate the velocity, you get the acceleration. When you differentiate the displacement, you get the velocity. So if you integrate the velocity, guys, you get back the displacement. And please do not forget to write plus c here, okay? Because that is a problem in these questions. You don't write plus c and then you are stuck and, like, simply choked. Okay, so I have been given 2 points here. One is this, other is, this is another pair of the information here. So, there's already one unknown k. When I'll be integrating this, there will be another unknown, that would be the c here. So can I say this x is going to be the integral of all of this, that is going to be k into, um, so this is k into t cube over 3 minus 5t square plus 21t, and then there is a plus c. Okay, so you will use this 3 and 2.85. You will have 2.85, that is k into uh, 3 cube over 3 is going to be 27 minus 45 plus 63, and then there is plus c. Someone please use the calculator and tell us that what is this value here. That is 90 minus 45, Hannah. That is 45k. Is that 45k? I'm handling
जी
this
sir.
differently. Okay, this is your equation number one. Okay, and then you substitute this point over here into the same equation here. So that will give you 2.4, that is equal to k into 6 cube over 3. Please put that into your calculator. Minus 5 into 36 plus 21 into 6, and then there is a plus c. Please tell me what is all of this. 2
सर ये t क्यूब ओवर 3 है तो वो 27 ओवर 3 नहीं होगा?
Oh, yes. So see, I'm doing that mentally. Please tell me the correct values here. So it is
फिर
9.
27 आता है मेरे ख्याल से
Okay.
आंसर फाइनल।
Yes. Thank you, beta. Thank you. This is 27. Okay. And what is here? What do you get here? Hmm?
18.
Okay, this is 18K. So you people, because I don't have the calculator with me, so you people are telling me all these values, okay? So these are the two equations. Please solve them simultaneously and tell me what is your C and what is your K. Yes, I think C will be 1.5 and K will be point. Please confirm that. And this will give us the equation that is going to be X equal to 0.05 into T cube over 3 minus 5t square plus 21t and then plus 1.5. Please check through your working if it is really correct. Okay, so the answer has been confirmed. Let's see what is there in the second part. Okay, it says find the displacement of the particle from A when its velocity is a minimum. Okay, when the velocity is minimum. So velocity is there with us. We can write the velocity as, we have this k that is 0.05, है ना? And that is going to be t square minus 10t plus 21. So when you have the minimum or the maximum, you people know that you have to find the derivative, है ना? So you people find that derivative and we put that equal to 0 so that you can find that time where the velocity is minimum, and you will put that t simply into this equation of this displacement here, है ना? So let's do that quickly. dv by dt, that is going to be 0.05 into 2t minus 10. So we put that equal to 0 and this is going to be t equal to 5. Now why he was so sure that the velocity is a minimum? Because one thing, you can find the second derivative, that will be simply 2, okay? And which is going to be positive, and therefore you will have a minimum velocity. Otherwise, the ones who are masters of quadratics, this they can see that the coefficient of t square is positive, so the parabola would be like this, and you can have a minimum velocity. ठीक है ना? Anyhow, guys, put this 5 back into this equation. Here you will get the displacement at the time when the velocity is minimum. So for that, this would be 0.05 into 5 cube over 3 minus 5 into 3 square plus 21 into, sorry, this is 5. I'm writing 3 here, into 5 and then plus 1.5. Can someone please tell me, or should I make a chop up from the this this is going to be, this has to be, yeah, 2.58 meters. This is 2.58 meters. That is the answer to the second part. Here is your B parts working. Okay. Okay, the last question of this paper, it says a particle P of mass 0.3 kg lying on a smooth plane. Okay, we like this word smooth because we don't have to determine the frictional force, okay? Inclined at 30 degrees, it is released from rest, okay? So here it is, its initial speed is going to be 0, okay? And it says distance of 2.5 meters, yes, and then reaches a horizontal plane. There is no change in speed when P reaches the horizontal plane, okay? So that means the speed at which it reaches the bottom of this inclined plane, that speed remains unchanged for the horizontal part of this journey. Okay, a particle Q of mass 0.2 kg lies at rest. Okay, this is also lying at rest. Okay, and it says on the horizontal plane 1.5 meter from the end of the inclined plane. P collides directly with Q. It is given that the horizontal plane is smooth. Chalo shukar hai, that is smooth as well. and that after the collision, P continues moving in the same direction, okay, with speed. Okay, now guys, you will have to be patient, okay. First of all, we need to determine that what is the acceleration of this particle P when you drop it, okay. So for that, you will have to find its weights component, because that would be the only driving force making it move down the plane here, Anna. So this is 30 degrees, so this is 3 newtons here, and this one is going to be 3 sine 30. Since it's a smooth plane, so let me write it as the downward force 3 sine 30 minus, there is no resisting force, that is equal to ma. We love this formula. This is zero point 0.3a, okay. So this is going to be 1.5 equal to 0.3a. So your acceleration is 5, and I'm doing all of this mentally. Please keep a check on my working, okay? Now, we have to find that what would be the speed when it reaches here. So we have the initial speed, we have the distance, we have the acceleration. So basically, I had to use this equation. That is why I found this acceleration here. So 2 is as is going to be v square minus u square, okay? So this is going to give me 2 into 5 into 2.5, that is equal to v square, and there is minus 0. So this v is going to be 2 into 5, 10, 20. So that is going to be 5 meter per second. That means when it reaches here, that is going to be 5 meter per second. And this speed remains same throughout. So it is going to hit this cube with a speed of 5 meter, because there will be no loss in the, I mean, that speed of the particle P, okay? So we can say that the momentum before the collision is equal to the momentum after the collision, okay? So guys, um, momentum before the collision, okay? The mass of this P is zero point 0.3, and before it is going to hit, its speed is 5, plus the mass of this is going to be zero point 0.2, and this was at rest. Now once it has hit, it says it is given that P continues moving in the same direction with speed 2. So that means we have zero point 0.3 into 2, okay? Plus, we have to find the speed of Q. So let's put that V times zero point 0.2, okay? So you have 1.5 equals zero point 0.6 plus zero point 0.2V. So this zero point 0.2V is equal to zero point 0.9. So your V is going to be 4.5 meter per second. Let's check the answer quickly if it is really correct. Yeah, that is correct. Here it is 4.5 meter per second. Okay, we didn't have to use calculator actually, है ना? Acha, guys, let's see what is in the B part. I hope this is clear to you, Hannah. It is given instead that the horizontal plane is rough. Oh, okay. And that when P and Q collide, they coalesce and move with the speed of 1.2 meter per second. Oh, let me put here some side notes here. So this is the rough part here, and they coalesce and their speed becomes 1.2 meter per second. So we have to find the coefficient of friction between P and the horizontal plane. Okay, guys. Let's go back here. Okay, and I want to see that how much the working that I can still use. Okay, one thing is quite clear, that when it reaches here, the speed will be 5. We can use this 5 here. Okay, but now the situation changes from now onwards. What do you think? Will the speed of this particle P remain unchanged when it moves from this point to this point Q? Hmm? Q, bachcho? Will the speed remain same, or will it be changing? Will it be increasing or decreasing? What will happen to its speed? Yes, bachcho, tell me
It will
quickly.
decrease.
Yeah, because now the surface is going to be rough here, है ना? Okay, so let me draw it here. This is the horizontal part. Now, suppose this P is moving here. Its weight is 3, and I can determine R over here. Okay. So there is no forward force, but there is a backward force, that is X. है ना? So we can determine that X equal to mu R. We don't have that mu with us, but we have the R with us. This is going to be 3 mu. Okay? So when it hits this, um, it is going to, they are going to coalesce, okay? And you have to determine this, um, its weight also would be determined here. That is going to be 2 over here, Hannah. And you can find the frictional force onto it as well. And this is going to be R over here. So the frictional force XQ, let me write that XQ. That will be 2R, bacho, है ना? Acha. Now this P is moving towards Q. Let's find its acceleration. ठीक है ना? So that is again, we're going to use F equal to ma over here. Now there is no forward force. There is a backward force, which is 3 mu, and its mass is zero point 0.3, है ना? And we want to find the acceleration. So the acceleration is going to be minus 10 mu. Yes, 3 over zero point 0.3 is 10. है ना? Hello? ठीक है?
जी सर.
Acha. Okay, now we have to find that the moment it reaches here, what will be its speed? You will have to find all that speed in terms of, um, you know, mu maybe. Okay. So let me write that rule here, and then the rule is that m1 into u1 plus m2 into u2, that is going to be m1 v1 plus m2 v2. ठीक है? So m1 into u1, let's assume that when it hits q, its speed is u1. So this is zero point 0.3 u1, and this one is going to be 0 here, and they coalesce. Their collective mass is zero point 0.5, and they are moving away with the speed 1.2. The speed 1.2, है ना? So this zero point 0.3, I changed my plan. Okay, I thought this would be easier. So that is going to be 6, है ना? So this u1 is going to be, that is the speed with which this p is hitting this q. So that is 6 over zero point 0.3. Oh, this is too much. This is 6 over zero point 0.3. Is
Sir,
this?
it's going to be 0.6.
Oh, thank you, Beta. Thank you, Savior. Okay. So this is going to be 2 meter per second. Okay. Now I can go back to this information that I collected here. The initial speed is 5. The distance covered is 1.5. The final speed is 2. Can we still use this equation here to determine this mu over here? क्यों बच्चों? Can I say that, uh, should I say that 2 into a, which is minus 10 mu, into the distance, which is 1.5, that is a final speed, v square minus u square, that is 4, and the initial speed is 5, that is minus 25. So you have 3 into, this is minus 30 mu, that is equal to minus 21. So your mu is going to be 0.7. Oh, let me see if it is really correct. Yes, thanks God. Oh, it was really a tough question, yaar. Oh, this is zero point 0.7. Guys, I was about to use this. I was about to find this speed with which it was about to hit the Q in terms of this mu, sorry. But I thought that this will make this more confusing. So I changed my plan, and I used this formula for the law of conservation of the momentum here to determine that what will be the speed before it hits that. So I got that speed too, and once I got that speed, the things became easier for me to handle. Okay. And this ends our this paper as well. Okay, thank you very much for being a part of our this past paper session.